Okay, so we're still on 10-2, multi-step equations, but this is example number 2. So here's the problem. And at first, this looks like a really challenging problem, but we can actually solve this in a very simple way, just using one more step to the actual process. Okay, if you take a look at this, notice that the denominators are all the same. And when the denominators are all the same, then adding fractions becomes very easy. And so what we could actually do is when we have the denominators all the same, we can think about just this top piece here, just this top piece to solve it. Need that too. Okay, and so when we solve this, what we would have to say is 5n plus 7 equals a negative 3. Because the denominators are the same, we can just look at the numerators on this. And then from here, we just follow the regular process that we had before, where we say, okay, we need to isolate the n, isolate that variable. So we have to first subtract both sides by 7. Here's my fence. Subtract by 7. This side will definitely cancel out. On this side here, though, okay, it's like, all right, I know there's a 3 and a 7. Okay, am I subtracting these because it's a minus 7? Okay, think about it like this. You have 3 negatives, and now we have 7 more negatives. And so what we would have to do is actually we're going to combine these negatives, which would give us negative 10. 10 negatives total. So now we still have this 5n on this side. So 5n equals negative 10. So we still have another step to solve this. So I'm going to slide it over here. I'm going to rewrite what we have so far. We have 5n, and we have our fence, which also means equals, negative 10. So 5 times something equals negative 10. Okay, to undo this, we would have to divide both sides by 5. Doing the inverse operation of what is happening to the variable. 5 divided by 5 gives us 1, 1n. Or you could say that they cancel each other out, and we're left with n. On this side here, we have negative 10 divided by 5, which would give us a negative 2. Remember that a negative times a positive is going to give us a negative. And this also works for division. So a negative divided by a positive will also give us a negative answer. Okay. If we take this back into the equation, take this negative 2 and bring it back into the equation, we're going to check to see if we get negative 3/4. So we're going to replace the n with a negative 2. So we have 5 times negative 2 over 4 plus 7/4 equals negative 3/4. Take care of the multiplication first. 5 times a negative 2 is going to give us negative 10. Negative 10/4 plus 7/4. Does that equal negative 3/4? So like I said before, when we have the same denominator with the fractions, we only need to focus on just the top. So really, you can think about this as negative 10 plus 7. Does that equal negative 3? And the answer is yes. This checks out. So the answer for this question is going to be n equals a negative 2. So on this section that has try this, you have a question that says that you have a question where the denominators are not the same. So for example, it says 5x over 9 plus x over 3 minus 13 over 9 equals 1/3. Okay, so with this, we're going to take a look at the denominators first because they're not the same, so we can't just isolate the top and look at it that way. But we can change this so the denominators are the same. So we're finding a common denominator. And it may already pop out to you that the common denominator for this will be 9. So everything that already is over 9, every fraction that has a 9 for the denominator, we don't have to change. This stays as 5x over 9. We need to change this to be over 9. Okay, so how do we do that? We have to multiply the top and the bottom. If you multiply the bottom by 3 to get to 9, we would have to multiply the top by 3 to get to 9. Okay, so this we're left with is 3x. This one already has the denominator that we need. And the last one here, we need to get it to 9. So we would multiply the bottom by 9 and also multiply the top by, we multiply the bottom by 3 and also multiply the top by 3. We have common denominators all the way across. So from here, we can just isolate just the top portion and solve it from there. I'll leave this for you guys to do. Try it and see what you come up with.